Life on Earth is shaped by sunlight, water, and gravity. But on distant exoplanets, the rules change. Locked in ice, crushed by gravity, or floating in endless skies, alien life would follow a path unlike anything on Earth. On Earth, life began with simple chemistry, carbon atoms forming chains, water acting as the universal solvent, sunlight feeding the first tiny cells. Every living thing here, from the smallest bacterium to the largest whale, follows this same blueprint. But on alien worlds, those starting conditions change. A planet closer to its star may use energy not from gentle sunlight, but from scorching radiation. A frozen world may shelter life not in seas of water, but in oceans of liquid ammonia or methane. Different chemistry, different rules, and yet the same drive remains: to grow, to adapt, to endure. Life elsewhere may not look like life as we know it, but it will be bound by the same universal laws of survival. Some planets are like Earth, but bigger. These super-Earths are rocky worlds several times our planet's mass. With greater mass comes greater gravity, pulling the atmosphere tighter, pressing oceans deeper, weighing on every living thing. Here, life would evolve under constant pressure. Animals could not grow tall and slender as on Earth. Instead, they would be broad, stocky, built low to the ground, their bones thick, their muscles dense. Flying creatures would face a heavier sky, wings stretched wide, perhaps membrane-like, built for immense lift. Forests too would change. Trees would rise shorter, with trunks thick and twisted, their branches pressing downward, shaped by gravity's hand. Even water would feel different, oceans denser, waves slower, every motion of life heavier, slower, more deliberate. On a super-Earth, life would not reach for the skies. It would cling tightly to the ground, thriving in a world where every step is a battle against gravity itself. Not all planets orbit in warmth. Many lie far from their stars, cloaked in endless winter. On the surface, oceans freeze into continents of ice. Winds sweep across barren plains. To the eye, such worlds appear lifeless. But beneath the frozen crust, heat still stirs. Volcanoes, geothermal vents, and the slow pull of gravity may keep hidden oceans liquid and alive. Here, life would be cut off from sunlight forever. Instead of photosynthesis, organisms would feed on chemical energy, hydrogen, sulfur, methane bubbling up from vents in the deep. In the darkness, eyes may never evolve. Instead, creatures might sense vibrations, magnetic fields, or pressure changes in the water. And in place of color, there would be light born from within. Bioluminescent organisms, glowing spheres, ribbon-like hunters, swarms of living sparks, illuminating black waters in ghostly displays. On such a world, life would never know the stars above, but it would thrive in silence, hidden beneath miles of ice. Some planets are forever locked to their stars, one side facing endless day, the other trapped in eternal night. On the day side, oceans may boil, deserts stretch unbroken, temperatures too extreme for complex life. On the night side, water lies frozen, landscapes locked in silence beneath an unending winter. But in between, in the twilight zone, lies a narrow strip where conditions may be just right. Here, winds carry heat from the burning side, ice melts from the frozen one, and liquid water flows in fragile rivers. Life here would be unlike anything we know. Plants might evolve reflective surfaces, shimmering like mirrors, to deflect the relentless sun that never sets. Others could grow black leaves, drinking in the faint light of eternal dusk. Predators may develop enormous eyes, tuned to perpetual twilight, creatures built to stalk shadows that never move. Entire ecosystems would stretch in a ring around the planet, circling endlessly. A world where life exists only in balance, forever walking the line between fire and ice. Some worlds have no surface at all, vast gas giants made of hydrogen and storms. For a long time, they seemed impossible places for life. But even here, in the endless skies, biology may find a foothold. In the upper layers, where pressure is less crushing and temperatures stable, strange floating ecosystems could form. Vast balloon-like organisms filled with lighter gases might drift through the clouds, feeding on chemicals carried by violent winds. Others could resemble great sails, gliding on jet streams, filtering energy from lightning and starlight. Predators may lurk deeper, massive and translucent, rising from darker layers to feed before sinking back into the abyss. Entire food chains could exist within storms that rage for centuries. Alien skies alive with creatures no eye has ever seen. On a gas giant, life would never touch the ground. It would drift, glide, and soar forever, in a world of eternal clouds. From crushing gravity, to frozen oceans, to skies without end, life adapts. The creatures we imagine may never exist exactly as we see them. Yet the laws of nature guide evolution everywhere. We are only beginning to glimpse the diversity of worlds beyond our own. Some may be barren, some may be alive, and perhaps among the stars there are beings looking outward as we do, wondering if they too are alone. Until we find them, alien life remains a mystery, but one written into the fabric of the universe itself.